Now going over to question 12, here we're hearing that this is a system of equations. We don't really need to be told it's a system. When you have more than one equation and we're being asked about the answer in any way, that's a system of equations. In other words, we're looking for the intersection of these two functions. And for an intersection, you want to get both equations in the y equals format and set them equal. So that would look something like this. X minus 2 x plus 4 equals 6x minus 12. Then we can start solving. We can FOIL out. We can do first times first, which is x squared, outer times outer, which is 4x, inner times inner, which is negative 2x, and last times last, which is negative 8. Now we can combine some like terms. Now we want to tell ourselves this is a quadratic. That means you should get everything on one side equal to 0, preferably with the x squared side being positive. So if we take away 6x and add 12 to both sides, we have this. Now we're in a nice BC factoring situation where we have a BC quadratic because we're looking at this in terms of having the A, B, and C coefficients. And notice that there's not really an A coefficient, but there is a B coefficient and also a C coefficient. So we're looking for two numbers. In BC factoring, we're looking for two numbers that add to B and multiply to C. And what two numbers add to negative 2 and multiply to positive 4? Negative 2 and negative 2. So x minus 2, x minus 2. Now the zero product rule says set each of these equal to 0. So of course, it's the same thing twice. So if x minus 2 equals 0, then x is 2. So we found the actual ordered pair that would do this. Well, at least part of it, we found the x value. Now we can just plug in to find the corresponding y value. Well, if y is 6x minus 12, then that's 6 times 2 minus 12, 12 minus 12, and that's 0. Now, a lot of people looking at this video might be wondering, well, why didn't we just put this into Desmos? Of course you can put this into Desmos, and I'm about to show you that right now. But to be ready for your SAT, you have to be ready for the easy questions and the hard questions. So you have to be able to do what I just did, even if there are some questions out there where it's not necessarily needed for you to do that method in this situation. But this is something you must be good at to be able to handle an SAT. Now let's show you the Desmos way. Now, if you went into Desmos and typed in y equals x minus 2, x plus 4, y equals 6x minus 12, you'd get the two graphs. Desmos has the advantage of being able to zoom in and out in case, for let's say, for some reason, you really needed to know exactly where these two things intersect. Desmos is pretty good at that. You can kind of just click in this area and it'll tell you where they intersect. It'll also tell you x-intercepts and things like that. Here, we just needed to know how many times they intersect. So now looking at this graph, it is actually quite ambiguous. The intersection is kind of hard to see. Maybe you could mess with the domain and range in the settings so you can really find out, is this thing overlapping twice or is it just kissing just barely once? But you know what? Coming over to Desmos kind of says maybe the algebraic method was actually better here because we know for sure that this thing hits at 2, 0, and there's one and only one answer. In any case, the answer here is C.